talked so far about what an amplitude can do to our graph, kind of stretch it vertically. We've talked about what a period can do. It can expand or shrink our graph horizontally. So now we're going to get into some other business. We're going to be looking at this thing called a k-value. And again, it can get placed on either end of our expression. You may get one sometime, and I don't think this would throw you for a loop, but just in case, it could get stuck at the other end, and it's going to represent an up or a down shift, a vertical shift of the graph. So, and we're also going to introduce with this something called the center line, which basically is, if I took my max and I took my min, finding kind of that middle value, or that midpoint where my graph would be moving from. So just like we've done with parabolas and all the other things that we've graphed, logs, if the k is positive, we go up that many. If it's negative, it shifts down. And we've already talked about amplitude and how it can make our graph stretch, reflect, and do some other things like that. So, I do want to mention one thing, though, with period before we get into the first example. New period is the old period divided by b. Just a reminder, sine and cosine both have original periods of 2 pi, and tangent just has a period of pi. Tangent's the oddball. So if we're ever trying to find a period, that's going to change things up a little bit. So on this first one, this is getting kind of crazy. I have an amplitude change, I have a period change, and I also have a vertical shift. So my k value is 3, which means this whole thing's going to get shifted up 3 once I get graphing. A equals 3 means we're going to take our base values and stretch them. And then my period, since we're working with sine, would be 2 pi divided by 2/3, which means we'll go through one complete cycle in 3 pi. So we've got our amplitude. We'll talk about the center line in a minute once we get some things graphed. I want you to be able to take a peek at these, and then we'll get that in here too. So I take a peek, and I go, okay, graph a period, label 3 key values and 5 key values on the x. All right, now, move this up a bit here. Here's how I normally tackle this, because I am not a big fan of doing a lot of playing on the calculator, and here's why. There's so many things that can go wrong. If you forgot it's in degrees instead of radians, things get messed up. If you put in the period and then your table set isn't right, it gets messed up. So you're like, well, what exactly do you want me to do then? Well, I know that my period's 3 pi. I also know, back from what we've been doing before, that my base sine graph works with these values. And again, these base graphs of sine and cosine are things that you need to be comfortable enough with that you can just sit here and I say, okay, what are the values for sine? 0, 0, pi over 2, 1, pi 0, 3 pi over 2, 1, negative 1, I almost screwed up myself, 2 pi 0. So now that I know my period has changed, I'm going to divide all of these by 3 halves, or in other words, divide by 2/3, multiplied by 3 halves. So remember, when I'm looking at these values, division by 2/3 is equal to multiplying by 3 halves. And here's why I want you to think about that. As you're coming up with your new values that you're going to put in for this, you're going to be multiplying all of my base theta values by 3 halves. So basically, here's what I'm going to be doing so you can visually see it now. If you want to do side work ever on these, that's okay. So I'd have 3 pi over 4 would be my first. And then pi times 3 would be 3 pi over 2. 3 times 3 is 9, so I'd have 9 pi over 4. And And then hopefully at the end here, 2 times 3 is 6, divided by 2 would be 3 pi. And if I've done my conversions right, that last one that I get will always be the same as when I calculated my period up here. So I'm feeling pretty good. But I still have to think about some other parts to this. So I go, okay, what are the other things I need to know? Well, my amplitude is 3, which means all of those typical values that I had here for sine are going to be multiplied by 3. That's going to be my first job. But then, on top of that, my k value is also 3, which means I have to go up 3. You're like, holy cow, man. So here's what I'm trying to keep track of. Okay, so normally sine is at 0, so 0 times 3, I do my amplitude first, is 0. But then I add 3 to it. So let me get some lines in here. So, okay, so I got 0 times 3 is 0, plus 3 is 3. Then I move to 3 pi over 4. This is normally a value at 1. So 1 times 3 is 3, plus 3 is 6. And if I understand my pattern well with sine, anytime I see a 0, I know it's going to end up back at 3. And that can save me having to do all the calculations every single time with this. When I do -1, when I get to here, -1 times 3 would get me to -3, but then add 3 back. If you know your base graph, both the radian measures and the y value measures, you'll have this. And my center line always is going to be the average, or the middle, I guess you could say, of my max and my min. My min's at 0, my max is at 6, my center line is going to be at y equals 3. So once you know that min and the max, head for the middle. That's going to be the center. And you might even start to see a kind of a pattern with that too as we start to do some of these. Ooh. All right, let's see what we got here. I'm going to let some of you do more talking on number 2 here. I wanted to make sure we got one in that was ready and raring to go here. All right, so number 2. 1 plus 2 cosine pi of x. Ooh. What's our k value on this one? 1. Okay, k is 1, so we're going to be going up 1 at the end. What's my amplitude? 2. So it means we're going to be multiplying our y values by 2. And what is going to be my new period this time? Right, my b value is pi, but what's 2 pi divided by pi? Plain old 2. You're like, well, how am I supposed to do that? Everything that we've had's had pi in it. Okay, but think about this for a minute. If you take all of your base values that you have on either of these and you divide them by pi, all that's going to happen is the pi is going to disappear and be left with a 1. So 0, 1/2, 1, 1.5, or 3/2, and 2. And there's my period. So I got 0, 1/2, 1, 1.5, or 3/2, 2. So getting the actual period down isn't that bad on this one. Hope I get myself some things to work with here. So now, I think about cosine for a minute and its base graph. So cosine normally starts at 1. So I have 2 steps I'm going to do with each of these. I'm going to multiply the y value by 2, Then I'm going to add 1. Okay, so at 0, my y value is 1. Multiply it by 2 gets me to 2. Add 1 gets me to 3. When I'm at 1/2, it's normally at 0. 0 times 2 is 0. Plus 1 gets me to 1. And then I start going, okay, I can see how this might work. When I get to 1, normally it's at -1. Times 2 would be -2. But then add 1 back. So we're at -1. I've already seen 0 before, so that's going to end up at the same place. I've already seen 1 before. That's going to end up at the same place. But it all comes back to the base graph, because all the stuff that I do with k and with a are to my y value. B, I'll even do this. B messes with my angle measure. A and K both mess with my y value. And I've got to keep those straight, because the only shift we haven't talked about is a phase shift, and that's going to be the other one that messes with my angle measure. Any issues so far? So it looks like I'm even going to hit to day 3 on the same note packet. I want to see, I want to do one more of these. Yes. We're going to slowly pick our way away at this homework assignment. We are going to get there. The unit circle just was too much fun. So, okay, so one more with our up and down shifts, and then we'll do the left and right stuff right off the bat tomorrow. We'll get there. All right, let's run down all of our values here. Number 3, K value. -2, which means we are going to be shifting downward 2. What about my amplitude? 2. So we'll be multiplying our y value by 2. And my b value? Pi over 2. Fun times here. So my period is going to be 2 pi divided by pi over 2. Otherwise known as 2 pi times 2 over pi, because I can multiply by the reciprocal. Those guys go away. My period's 4. So that's kind of nice. The period of 4, I don't have to do too much thinking, because we always have those 4 lines out here, so I can just count them off. Or I could go back to my base graphs. So I look at this and I go, okay, let's see. Get some lines working here. All right, so we're starting at sine. Sine starts at 0. So we got 0 times my amplitude would still be 0, but then I'm going to go down 2. So I've got my first point. Normally, when I'm at sine on my next one, normally I end up at 1. Okay, so 1 times 2 would get me to 2, but then I'm going to go down 2. So back to 0 I go. And then you're like, oh, so anytime there's a 0, you're going to be at -2, which is absolutely correct. Save yourself some time. But when I'm at this one, which is my 3, I start at -1, times it by 2, then go down 2 more. And play connect the dots. And we actually are at about the center line again, which again is just max at 0, min at -4. Center line's going to be at -2. So as we keep pressing along, now you are capable in the packet that we started yesterday. Yesterday we were good up through number 7. We are now good up through number 14. So we have twice as many problems we can do now. And tomorrow we'll deal with our phase shifts, which will basically get us through this and on to the next part. So keep playing with the unit circle, but also if you haven't started on the packet yet, get yourself a bit of a start so at least you can have those things ready by tomorrow when we have all of this ready to go.